This final video for Chapter 7 is going to discuss the adaptations our body can make when food is limited, or you're on a starvation diet, or a very restrictive diet. So when we eat too much, we're already aware that our metabolism favors fat formation. So if you overeat any of these macronutrients, proteins, carbs, or fat, your body is going to turn them into fat. Carbohydrates that we turn to glucose can either be, well, first, they usually fill up our liver and muscle glycogen stores. And then if there's any left over, we will store it as fat. Fat, we use it typically to store, if we have extra, we usually put it in our fat stores. And for protein, after we use what we need to make our body proteins, if there's any left over, that too can be stored as fat. So, our cells need energy all the time, and two-thirds of the energy that we use is used basically to keep us alive. The other third is used for you to do whatever you want to do, all those voluntary movements like, going to the gym or even just watching TV. These are all voluntary movements as compared to our life processes. And how do we keep our energy up? We keep eating. We refuel our body every several hours, or often several times a day. And when you don't eat, we consider that fasting. So when you're sleeping, your body goes into a fasting mode. If you cannot access food, and there are millions of people in the world that are starving, it's because they have no access to food. And your body, what happens whether you're fasting or starving, your body will turn to the stored tissues that we have to provide food or fuel for your body. So your body doesn't know the difference. It can't tell the difference whether you're just fasting for a short period of time, like when you're sleeping or possibly on certain kinds of diets, or whether you're starving. It doesn't know the difference. And so it adapts to this lack of food. Our body relies on its reserves of carbs, which is glycogen. That's the only storage form of carbohydrates in the body. And fat, right? Fat is where we store most of our stored energy. And within a day, it turns to protein. It will start to break down our muscle tissue to provide the substrate necessary to make energy. So if you are fasting for long periods of time, it will first start to break down your lean muscle mass, which is your muscles, and it will use that to make energy. So after you eat a meal, right, we have glucose, glycerol, and fatty acids are used as you need them. If you need energy, we'll use those for energy. And any time you have an excess that we don't need any more energy, we store it. When the body shifts from that fed state after you've eaten to a fasting state, going a few hours without food, it draws on these stores that we have stored away for these times, for times when food is not available. And your body will first release that glycogen from your muscles and your liver, and also some fat is released from its storage facility, wherever you're storing your fat on your body, to provide glucose. Glucose comes from glycogen, and when we break down that fat that we've had in storage, it gets broken down into glycerol and fatty acids. There's only a limited supply of glycogen, right? I think I mentioned that it's like the tiny gas can that you keep for emergency use. And once you've depleted all of your liver glycogen, your blood glucose begins to fall. and our body will then adjust its normal metabolism, which we've just gone over. Normal metabolism is using the TCA cycle to create energy. Your body will adjust to survive without food. So when we're fasting, right, our liver and muscles store glycogen, which we can then break down and use it for energy. Your body loves glucose, but your brain and your nervous system and your red blood cells all prefer glucose. It is their preferred source of energy. Your body fat stores can be broken down into glycerol, which we can make glucose out of, and fatty acids, which we can make energy out of. Remember, we can break these all down into a whole bunch of acetyl-CoAs that we can use in the TCA cycle. If you don't eat for a while, your body is going to require glucose. And our body can make glucose. We can actually reverse glycolysis. So if you have a whole bunch of pyruvate, we can actually generate glucose from pyruvate. So that term is called gluconeogenesis. And this is the pathway. So on the left side with the red arrows going down, that's glycolysis. And on the right side with the blue arrows going up, that's pyruvate to glucose, is gluconeogenesis. And we can use amino acids to do this. So some amino acids can be turned into pyruvate, and those that can be turned into pyruvate can be used to create glucose. And again, who's going to want this glucose? If you're not eating carbohydrates or anything and you don't have a lot of glucose, your body is going to use amino acids to turn them into glucose so that your brain can get the glucose that it desires. So this is an expensive way to make glucose because you basically are breaking down your own muscle tissue in order to feed your brain. And this happens first, and then the body slows this process down. It switches about 1 to 2 days after this has happened. The body switches to using fat to provide the energy that your body needs so that you don't break down all your lean muscle tissue. If it continued at the same rate for a number of days, I think the book says 2 weeks, 2 weeks you would break down all of your muscles, including the muscles of your heart, and that would probably kill you. So after we've switched our fuel usage to fat, we can use the acetyl-CoA. The fatty acids can be turned into acetyl-CoA, and that acetyl-CoAs can be turned into ketone bodies. And ketone bodies are basically keto acids, and our brain can use them for energy. It prefers glucose. Let's be straight about that. It prefers glucose. But if you're not able to make glucose because either you have no food available to you or you're following a diet that doesn't provide glucose, then your body can turn fat into ketone bodies that your brain can use for energy. Your brain can use them, and all the cells in your body can also use them to create energy. So during prolonged starvation, remember I said that oxaloacetate is a limiting factor. If you are starving or fasting for long periods of time, this oxaloacetate gets depleted. And remember, if you don't have that oxaloacetate, then you can't run the TCA cycle because that has to combine with acetyl-CoA to make citrate. And if you don't have enough of one of those, it's not going to run. So the acetyl-CoA, since we can't use it in the TCA cycle, our body turns into ketone bodies that can be used elsewhere. And that's basically what this says. Our body will break down our body proteins, mostly muscles, into amino acids, and we can turn some of those amino acids back into glucose for use by the brain for its energy. But if we don't make glucose, we can turn them into, if we turn them into acetyl-CoA, we can then turn them into ketone bodies that our body can use or our brain can use for energy. And fat works the same way. Fatty acids can be turned into acetyl-CoA, which can also be turned into ketone bodies, and we can use those for not only the brain and the nervous system and the red blood cells, but we can use them for all different types of cells for energy. So your body adapts. It adapts to whatever you're doing or whatever food you're putting in or not putting in. It can change the hormones that it puts out so we can slow down our metabolism. It reduces your energy output so it doesn't let you spend a lot of energy. So in a starvation mode, you might be tired and weak, and you may just want to lay around all day. And that's your body's way of conserving energy. And it also conserves fat. So people who follow a very restrictive or low-calorie diet thinking this is the way I'm going to lose weight, it usually doesn't work because our body tends to hold on to the fat just in case it needs it as an energy source later on because it doesn't know when you're going to feed it again. So it conserves fat and muscle tissue. And the body does this so that it can keep us alive. So remember, we can only go a few days without water, but we can live for about 2 months without food, depending on, your body size. I mean, everybody is different, but this adaptation allows us to stay alive in the absence of food. So fasting will produce weight loss. It's not the best option for fat loss. It takes a long time and your body adapts to whatever you're doing. So it will hold on to that fat. And if someone has type 2 diabetes, we should not try these fasting diets because we need to keep our blood sugars at a nice even level. Which brings me to the ketogenic diet. So the ketogenic diet is a low-carb, high-fat diet. It was originally created in the 1800s to treat epilepsy, which is a seizure disorder. And it does produce weight loss. Many people have had some success with the ketogenic diet and losing weight, but it's hard to maintain. And one of the reasons is because you're excluding these types of foods here. You're excluding the bread, pasta, all types of sugar, milk, corn, beans, rice. These are things people like to eat. And you're having to eat a lot of the meats, fish, poultry, eggs, cheese, oils, not a lot of fruits and vegetables, and not a lot of nuts and seeds. So it is kind of hard to maintain. And what happens when the people that are on a keto diet, as soon as they eat something that has carbohydrates in them, your body goes back to its normal metabolism. It stops producing ketones and goes back to using glucose for energy. So there are some adverse side effects of the ketogenic or low-carb diets. Nausea, fatigue, constipation, poor energy or mental function. A lot of people talk about being in a fog when they first start this diet. because our body is adapting to using ketones for energy instead of glucose. So our brain, it takes about 5 to 7 days for your brain to completely adjust to using ketones instead of glucose. It can exacerbate kidney disease or cause kidney stones. It leaves a very bad taste in your mouth, and pregnant women definitely should not try this. Try the ketogenic diet or a low-carb diet. So carbohydrates are your body's preferred fuel. It's what it wants. That's what our normal metabolism uses. Mostly, it's our preferred energy source. So we have to eat the right carbohydrates. You have to eat whole grains and carbohydrates from fruits and vegetables, and stay away from the simple carbohydrates, the refined carbohydrates, things that have a lot of, sugar and white flour in it. These are those empty calories. So we want to stay away from those. This is just a big chart of all those. I had broken it up in this PowerPoint presentation. So this is in your textbook if you want to take a better look at it. And in summary, you should be able to do all of these things. You should be able to identify the nutrients involved in energy metabolism and the high energy compound that captures the energy released during their breakdown. So all 6 classes of nutrients are involved in energy metabolism. Carbs, proteins, fats, vitamins, minerals, and water are all involved in energy metabolism. And ATP, adenosine triphosphate, is that high energy compound that captures that energy. You should be able to summarize the main steps in the energy metabolism of glucose, glycerol, fatty acids, and amino acids, and explain how if we eat any of these 3 energy yielding nutrients in excess, how that contributes to body fat, and how an inadequate intake of any of them shifts metabolism. So that's chapter 7.